Hey everyone, welcome back, and today let's solve Leetcode problem 6 titled Zigzag Conversion, a very classic Leetcode problem. So the string PayPal is hiring is written in a zigzag pattern on a given number of rows like this. We may want to display this pattern in a fixed font for better legibility. So we have pay, we have pal, we have is, we have hiring. Right? And we need to read this line by line as pawn app and however you would like to pronounce that. I'm not going to try to finish that. So we need to write the code that's going to take a string and make this conversion given a number of rows. We have a return type string method convert, and we're taking in two parameters, string s or s, a parameter of type string, and the number of rows parameter of type int in this return type string convert method. So in example 1, we have our input string s to be PayPal is hiring, the original example given in the problem statement as well, and we have the number of rows to be 3. If you want to go back to the image, this is how we would actually put this into 3 different rows and format these corresponding adjacent elements accordingly. And so if you would actually read this row by row, you get P, A, H, N. That's the first row. Then you move on to the second row, which is A, P, L, S, I, I, G. And then you move on to the last row, which is Y, I, R. If you want to just combine them into one string, you'd read this, 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 all concatenated or joined into one string as the following. Okay? So that's the reason why we output this output string, given the number of rows that we have, to merge, or rather, kind of shift our original input string as into. So in example 2, we have the same kind of string here, PayPal is hiring, but instead we have 4 rows, okay, and our output would be the following. Why is that? Well, because they give us a nice visual example of why and how we can actually split this original input string s into 4 different rows. We'd have pin, we'd have this, we'd have this, and this. Notice how we have 4 different rows, and all of the corresponding letters are split in their according rows based on their index in our input string s. And finally, we have in example 3 an input string s of length 1. We have one uppercase A, and we only have 1 row. Well, we only have 1 row in our output as well, and it's going to be the single character in our input string s as well. It's going to be the single uppercase A that we are inputted. So, with that out of the way, I will give you guys a few seconds. I'm going to just go over this problem in your head and think of a valid solution. And then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so first, what are some kind of possible edge cases that we can look for in this problem, where we don't actually want to go in to start computing our regular main code, just some edge cases kind of just go it over with to see if we have any weird cases. Well, if there's only going to be 1 row, where our input string, or rather integer num rows is equal to 1, then we know, or actually, I guess we'll have 2 cases, so let me actually comment this out. So, when there is only 1 row. Well, if that's the case, then we know that this input string s is just going to be itself, right? We can't actually split other elements into other rows because we only have 1 row, right? We can only split whole input string s in 1 row. No change. And I probably butchered the spelling of half of these words here. Should be off. Okay, so that's our first base case. But what's our second edge case that we have to handle? Well, what if the number of rows actually is greater than the string length itself? What if in this case we have like A in our input string s and num rows to be 2? Well, we can't split 1 character into 2 separate rows. We just don't have enough characters to do that, right? That's another edge case that we have to handle, right? When I don't know why I have caps lock on. When the num rows integer input is greater than the length of input string s, where you don't have enough characters to actually split it into according to our num rows input. Okay, so that's just going to be the kind of zigzag pattern like edge case, right, where if we have this, it's going to be the zigzag pattern itself, or for this second edge case, it's going to be invalid, and we just have to output like false. But now we have to actually, once we've done kind of handling these edge cases, we have to actually start our main code, our main zigzag algorithm. Now, how is that actually going to be formatted? Well, we're going to have a kind of rows data structure, right? It's going to be a list of strings where each element or string in that list is going to represent one specific row in that zigzag pattern. And we're also going to have a current row variable, which is simply going to keep track of the current row that we're currently populating or taking elements from and putting into that current row from our input string s. And finally, we're going to have a kind of going down variable, right, which is going to be a Boolean value to actually determine the direction of movement in that zigzag pattern, either down or up, right? So first we're just going to traverse each of the different characters in the string, and we have to place the character in that appropriate row. Once we've actually placed it in its corresponding row and in our actual rows list, then we have to actually change the direction when that either top or that bottom row is actually reached. And effectively, once we're done with all the rows, we have to merge all those rows to actually form the final zigzag string, which is what we have to actually output, our result. So with that out of the way, let's just go ahead and dive straight into the code here. So like I was talking about just now, we have to first handle our edge cases. Well, the first edge case is, what if the number of rows, what if that's equal to 1? Well, if that's equal to 1, we simply have to return s. But there's also another edge case to handle. What if the number of rows, or number of rows, that is your input, what if that's greater than or equal to the length of our input string s? Well, in that case, we can just simply return s itself, because there's no other ways we can actually split s into some other number of rows, because either we don't have enough letters, or we just only have one row. We don't have any other rows to actually split any other elements from our input string s. And this is just our base case, because a zigzag pattern with one or more rows that actually exceeds the string length is basically just going to be a straight line. It's going to be one dimension, and so no conversion is needed, right? I mean, obviously, technically all of these are one dimension, except for these. This is two dimension, but whatever. And let's not get into that right now. So, now we have to actually initialize our rows list. Well, I'm going to have rows. It's going to be initialized to a string, and its length or dimensions is going to be the number of rows that we actually have, or again, integer input value or parameter. Okay, it's just going to be initialized again with empty strings, and it's going to have dimensions of number of rows. It's going to have a list of an empty string times the number of rows that we actually have. Or again, each element in this list is going to represent one row of the zigzag, right? We're going to have this number of rows, or number of rows in our rows list, right? Where again, each element is going to be basically representing one row of the zigzag list, right? Okay, so now let's actually initialize our current row variable that we're currently populating. So we're going to have current row, and it's going to be initialized to 0, right? Right, and this is going to just keep track of that current row that we're actually populating or filling with characters from our input string s. Now, we're going to initialize going down to be false. So going down to be false, because of course we haven't actually started building our rows yet. We can actually update this Boolean value once we've actually started building our rows, right? It's simply going to determine whether our traversal is moving in which direction, right? Is it moving downward or upward in this zigzag conversion, or in this zigzag pattern? Now let's actually start iterating over our input string s to actually build our rows and kind of change which row we're building, and if we're going downward or upward, and the direction we're actually building with. So for every character in our input string s, right? For every character or char in our input string s that loops over every single character in our input, we have to set rows at that current row to be updated or incremented by that current kind of element char, or that current string char, right? We're simply adding or appending the current character char, what we're using to iterate over, to our string in the current row of that rows list. At that index current row in this rows list, we're just appending or adding that char variable, whatever that is, whatever that string is. But we have to have a quick conditional here. If the current row, I'll go over this once I'm done kind of coding it up. If the current row is equal to 0, or the current row that we're currently building up, well, is it equal to, is it equal to the number of rows, or again, our input, minus 1? Well, in that case, we just have to set going down, I think, yeah, okay, I had an underscore there, okay, to be equal to not going down, right? Basically, it's kind of inverse, right? If it was true, it'd be false, or if it was false, it'd be true. Well, why are we doing this? What does this even check in the first place? Well, first we have to check, is our current row at the top, right? Is it 0? Or is it at the bottom? If it's at the bottom, it would be at the last index, or num rows minus 1, or the last row. And if that's the case, we have to reverse our direction by simply changing or kind of modifying going down, right? If it was true, it'd be false, or it's not. Or if it was false, it'd be true, right? It's not. Basically the opposite of its current value, right? Or either true to false or vice versa, right? If the current row is 0 or number rows minus 1. If it's the first or last row, we have to actually change our direction of where we're actually building our rows with. Now, once we do that, now we can actually increment our current rows. Oops, okay. We can actually increment our current row by 1, but we can only do this, well, we have to know if going down is actually true. And in Python, we simply say if going down, right? Because if going down, we simply check if it's actually a Boolean or false, right? If it's actually true or false. But if going down is false, then we have to set it to -1. What are we doing here? Why are we incrementing current row by 1 or -1? Well, we have to increase our current row by 1, just move on to the next row, if going down is true, right? If we're actually moving downward. However, we have to decrease current row by 1, so add it -1 to it, if going down is false, so we're moving upward, right? That's the simple kind of sketch of how that would work. And it looks like I just deleted this geo. Sorry about that. If going down is true, technically I could have equals true. I'm just gonna keep it like this for simplicity. You guys can have this in your code if you'd like to. It's the same thing in Python, but I'm just gonna have if going down. Else we have to decrement the current row by 1. I don't know why there's. Okay, now I should be fine with misspelling errors here. I'm not sure. Anyways, so once we've done that, once we've actually built all the rows and changed the corresponding direction at that point, after actually building those rows, we simply have to return the rows list. However, we don't want to output the number of rows and the different rows we have as an actual list or elements as strings in a list. We want to just output it as an actual string. And how do we do that? Well, in Python, we can use our string. Okay, sorry about that. We can use our string dot join on the rows, right? What does this do? It simply concatenates all the different elements in this rows list and joins them into one string, hence the name string.join. We're simply just joining all of the strings or elements in our rows list into a single string, concatenating it into a single string, and simply returning it, right? It's going to be the final zigzag representation of the different ways we built it up or populated it as we change our direction and moved either forward or upwards. Okay, so now as you can see, unless I made any syntax errors here, this should work. Okay, let's see what I did wrong here. Okay, I forgot an equal sign. Sorry about that. Now this should work. Now this should be a valid solution. And as you can see, this is actually just about as efficient as you can get. So to kind of reiterate what this code does overall, we're simply just handing our trivial or kind of edge cases here. If we only have one row or the number of rows we have is more than the number of elements we have, in that case, we simply have to return our original input string s because we can't actually kind of split it into a different number of rows or ways, right? Then we have to actually start iterating over the characters of all of our strings after initializing these three variables that we work with. So for every character in our input string s. And once we do that, we have to place each character in its appropriate corresponding row based on our current direction going down, right? If we change how we change our current row. Then once we do that, we have to actually change our direction whenever we hit the top or the bottom of the zigzag, right? If we're in the first row or the last. And once we do that, once we've actually changed the direction, we simply have to combine all of the different number of rows we have in our list as different elements into one kind of full string to actually produce and return that final zigzag string based on the number of rows we have and when we actually change directions once we're done building the string and we hit the last or very first index. So for the time complexity, this is going to be a big O of n solution. Why? Because we just really iterate over our input string as once, right? We're at most going to be checking exactly at most going to be checking every single element exactly once with one for loop. It's a one pass solution, right? It's going to be proportional to the length of our input string s1. All right, and every single character is going to be appended in our rows, and so it's going to be, again, a big O of n runtime solution. And for the space complexity, this is also going to be big O of n. Why? Because we have to actually use this extra data structure or auxiliary memory of this rows array. It's going to have, or rather use additional memory to actually store all the different rows that we actually build up and change directions for that zigzag pattern, which is also going to be proportional or equal to our input string s length. Right, it's going to be the same length as our input string s because, of course, we have to actually store all the characters that we actually put in different rows in this rows array. So for the space and time complexity, they're both going to be linear time solutions or big O of n solutions, and that is actually be it for today's video. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye bye.